We are going to be looking at effects of parameters on trigonometric functions. But before that, I need us to discuss the meaning of an absolute value. Ne? So if I have an absolute value of 3, the answer would be 3. If I have the absolute value of negative 8, the answer would be 8. If I have the absolute value of negative 5, the answer would be 5. If I have an absolute value of 4, the answer would be 4. I'm sure, ladies and gentlemen, we can see that the output of an absolute value is always positive, irregardless of what the input is. Right. So we're going to use that a lot on amplitude. Ne? Basically, this number here, or this parameter A, will help us to find the amplitude of both the sine and the cos graph. And they are exactly the same formula. So an amplitude, I'll just say amp for amplitude, it's always given by the absolute value of A. In simple terms, we are just saying that regardless of what the value of A is, whether it's positive or negative, the amplitude is always positive. Right. That is the first most important thing. And we know that the amplitude is basically half the distance between ymax and yminimum. So we take the y on the minimum turning point and the maximum turning point. We do the positive difference and then we divide by 2. That will be another way to get the amplitude from the graph, right? Obviously, this one, you take it from the equation. These two, you are going to do it graphically. Alrighty. That is the first thing. Secondly, we need to know how to get the period. The period of a sine or a cos graph will always be given by 360 over the b, where the b is the number just before the x. In this case, it's gonna be k. So I just use different letters to show that it's not always going to be b, it's not always going to be k. They can put any letter there. You just need to know the positions. So whatever number is just after your sine or your cos, it's your period constant. To get the period of a function, you are going to use 360 divided by that. Should give you the period. And then from here, ladies and gents, we can agree that if I switch the period and b, I can have b as the subject of the formula like that over the period. So in essence, what I did, I cross-multiplied first. So I had b times period, then I divided by period both sides. All right. So this form you are going to use if you are looking for the period from the equation. This one, if you have the equation, you're going to use that one. Then if you're looking for the equation, you have the graph, you're going to use this one. So 360 divided by the period will always give you the period constant. Right. And the formula for ymax and ymin must be known. Ymax, ladies and gentlemen, is basically the q plus the amplitude. It's basically the q plus the amplitude. So it's q plus, remember the amplitude is that, the absolute value of A. And then the y in the minimum is going to be q minus the amplitude. Alrighty. And we also need to know how to find the range. The range of these functions is going to be always ymin is to ymax, and then we must show y elements of real numbers in the front of the bracket, and you must always use square brackets because the y values are also included. Right. And the domain is usually given. which refers to the x values of an all real numbers, right? So the domain is always going to be given to you on your questions. All right. Now I need us to discuss the effect of each parameter. What does it actually do? Obviously, Q moves the graph up and down. Up. If you see here you have a plus, so if Q is positive, you're gonna have a overall of a positive sign, so you're going up. And then if you have a negative, you are going down in this case, né? If you have a negative. And then here you see you have a minus. So if M is positive, you are going down, né? Because you already had a minus there. So a positive and that minus will give you a minus. And if M is negative, you are going up, because you're going to have negative times negative M, which is going to end up being positive, so you end up going up, né? And remember, P moves left and right. Left, if P is positive, you are going to the left, and then you are going to the right if P is negative. For this one, you already have a negative sign here, so you are going to the right if B is positive, because you're going to have a positive and a negative, which end up being a negative, and a negative means to the right, remember. And then to the left if B is negative. So it entirely depends on the original sign that you have in front of your parameter. But remembering that generally overall plus sign is up, overall minus sign is down on Q and M, né? And on P and B, the overall plus sign means left, the overall minus sign means right. So it's left and right, it's opposite, remember, right? Perfect. So you look at the sign on front. So here it's minus, for instance, and then you check what is going to happen if you are putting a certain value of B. For example, if I put a B that is negative, I'm going to have negative and negative, which will give me positive. So the overall sign will be positive, which means I'm going to the left. I hope that makes sense, ladies and gentlemen. And then A basically vertically stretches the graph. So A is a vertical stretch and B is a horizontal stretch or compression. And also A is a vertical stretch or compression. If A is not 0 point something, we are stretching. But if A is 0 point something, we are compressing. All right. And if B is 0 point something, we are stretching. If B is not 0 point something, for example, if B is 2, then we are compressing. So it's opposite. Vertical stretch and horizontal stretch are opposite. Right, so we're going to talk about that now. I need to do the first example with you, ladies and gentlemen. Let's say we are given f of x. Let's say we are given f of x equals to minus 2 sine half x plus 30 degrees minus 1. And the first question asked me to describe the transformation that happened from the mother graph. Remember, the mother graph would be y equals to sine x. So we need to know what happened from the mother graph. The first thing I'm going to do is to list all my parameters. I can see that my A is minus 2, my B is half, my P is plus 30, which means I am shifting I am shifting 30 degrees left. Okay, my Q is -1. As we can see here, our Q is -1, which means we are going 1 unit down, right? I'll just say 1 down, 1 down. And then those are the 4 important parameters, right? Now, let's see. You always check the sign here. Ne? The sign in front here tells you something. It tells you that we have reflected this function along the x-axis. Ne? So here, we reflect. If it's negative, it's always reflect along x-axis. And because we have a that is more than 1, is not 0 point something, it means we are stretching. If a was 0 point something, we would be compressing. So we're gonna say vertically stretch by a factor of 2. All right. So we're vertically stretching by a factor of 2. Now let's look at B. The B tells us something about horizontal stretch or compression. Yeah? So the B is 1/2. It's always opposite. You reciprocate when you talk about the stretch or the compression horizontally. So for example, if I reciprocate this, I'm going to have 2. The reciprocal of half is 2, which means I am actually making my x values bigger. So I am stretching. So this is a horizontal stretch by a factor of 2. What I mean is this, ladies and gentlemen. If I have B equals 2, let's say 2, then when I reciprocate this, I see that I'm getting 1/2. Now this would be a compression. So I'll say vertical compression by a factor of half. I'm sure that makes sense, ladies and gents. Right. Now, the next question wants us to find the period of this function. Remember we said period for sine and cos, it's always 360 degrees divided by b, right? And in our case, we said b is half, so we're going to have 360 degrees divided by half, which will give us 720 degrees, which indeed is true that we have stretched the graph because the period got bigger now, you see? So there is indeed a stretch that happened horizontally. All right. Now we need to get the minimum, maximum, and range. Remember we said max, ymax is basically q plus the amplitude, which is the absolute value of a. And what is our q in this case? Our q is going to be -1 and a is -2. Okay, so it's going to be -1 plus absolute value of -2, which is -1 plus 2. Remember, the absolute value, even if we have a negative, it outputs a positive. It's just the distance from 0 or from the origin to a certain x value. And then this will give you 1. So the maximum value is 1. Alrighty. Now we're going to do ymin. We have a maximum value of 1. Let's see the minimum. You have q minus absolute value of A, which is the amplitude, which give us -1 minus -2 absolute value, which will give us -1. There's a negative outside. The absolute value of -2 will just be 2. So the minimum value will be 3. And then the range of this function would be y elements from the minimum to maximum with square brackets because they are also included. All right. And that's it with this video. Ladies and gentlemen, we are now going to do the second example, of which I'm going to advise you to pause a little bit and try it on your own, then resume. And the function is g of x is equals to -half cos 3x minus 45 plus 2. And the first thing I need us to always get used to is to list our parameters. We can see that A is -half, B is 3, and then P is minus 45 degrees, and then Q is positive 2. And this, each and every parameter tells a story. Remember I said if we have a negative, it means we reflected in the x-axis, reflected along x-axis. And then now we have half. Half basically means compression because it's 0 point something. So we vertically, remember A is vertical, vertically compressed by a factor of half. Okay, I'm going to remove B there, ladies and gents. B is 3, but I'll just write it at the bottom so that we can have space. B is equals to 3. What does B tell us? Remember I said to know about B, just reciprocate it. You have 3 over 1, so the reciprocal is 1 over 3. This is the factor that you did, the horizontal. So, and you can see that it's 0 point something, which means you basically going to compress. The period is getting smaller now. So we're going to say horizontal compression by a factor or with a factor of 1/3. All right, so the period is going to be shrinking here, and we'll see that as we compute the period. Minus P being minus 45 means we are going to the right, 45 degrees to the right. We moved 45 degrees to the right, and then here you move in 2 units up. All right, and that is the transformation that the mother graph, of course, underwent. Now let's find the period. The period is going to be 360 divided by B, which is 360 over 3, which is 120 degrees. Original mother graph period is 360. The graph's period that we have is 120. We can see that indeed we had a horizontal compression. All right, now we're going to do max and mean, ymax and ymin. Ymin we're going to have q plus the absolute value, q minus the absolute value. What is our q in this case? Our q was 2. So our q was 2 plus the absolute value of, is it negative half? Absolute value of negative half, which will come out as 2 plus half, which is 5/2 or 2.5, right? That is our maximum. And then obviously here we just change the sign there, then that will be half, which is 1.5. All right, so basically what I did is I just wrote this part here, but I know that this sign will now be a minus. It's always just switches, and then that gives you a minimum y value. And then the range would be y elements from 1.5 coordinate 2.5 with square brackets to show that this has been included as well, right? Ladies and gentlemen, if you made it this far, you have officially outsmarted your cousin and probably your gogo too. Keep pushing, keep trying, and if you laugh while learning, remember better. Like, share, subscribe, and go teach someone else. That's how you master it. Tango.